when upgrading a plant belt drive motor, and it is approximately 600 feet from the breaker in the motor control center room, several factors need consideration regarding grounding. The motor is a 100 horsepower 460 volts alternating current delta feed. The plan is to use a 3/0 copper THWN feeder in a 2-inch rigid conduit along with a short section of raintight flexible metal conduit at the motor for vibration isolation. The question arises whether an external ground wire from the motor to the rigid conduit is necessary, or if relying on the internal ground wire within the conduit is sufficient for National Electrical Code compliance. According to the National Electrical Code, specifically Article 250.118, a metal raceway-like rigid conduit that provides a continuous electrical path back to the service entrance or the main distribution panel is permitted to serve as the equipment grounding conductor for the electrical equipment connected to it. In this scenario, the 2-inch rigid conduit establishes a continuous and robust path back to the motor control center room where the electrical service originates. Therefore, the internal equipment grounding conductor, typically a green insulated wire or a bare copper conductor run within the conduit, should be sufficient to meet the National Electrical Code requirements for grounding the motor. This eliminates the need for an additional external ground wire running from the motor enclosure to the rigid conduit. However, it is crucial to ensure that all connections within the grounding path are secure and properly made to maintain electrical continuity. Regarding the use of raintight flexible metal conduit, the National Electrical Code permits the use of listed flexible metal conduit or liquid-tight flexible metal conduit, along with an internal equipment grounding conductor, for short sections where flexibility is required to accommodate movement or vibration. This is applicable in the case of the motor connection to prevent the transmission of vibrations through the rigid conduit system. The raintight flex must be securely connected to both the rigid conduit and the motor junction box using approved fittings that are specifically designed for this purpose. These fittings ensure a reliable mechanical and electrical connection, maintaining the integrity of the grounding path. It's important to select the correct size of the flexible metal conduit and the internal grounding wire based on the motor's full load current rating, as specified in National Electrical Code Table 250.122. This table provides the minimum size requirements for equipment grounding conductors based on the overcurrent protective device rating in the circuit. It's important to also verify that the overcurrent protection device is properly sized for the motor in accordance with National Electrical Code 430.52. When installing the system, there are several additional considerations to keep in mind to ensure proper grounding and compliance. Firstly, it is essential to verify that the rigid conduit and the raintight flex are appropriately sized for the motor's current draw. This ensures that the conductors within the conduit are not overloaded, which could lead to overheating and potential safety hazards. The conduit size should be selected based on the number and size of conductors being installed, following the fill requirements outlined in National Electrical Code Chapter 9. Secondly, use only Underwriters Laboratories listed or other nationally recognized testing laboratory approved fittings to connect the conduit to the motor and the flexible metal conduit sections. These fittings are designed and tested to provide a secure and reliable electrical connection, as well as to maintain the integrity of the grounding path. Using non-approved fittings can compromise the safety and performance of the electrical system. Thirdly, it is crucial to ensure that the motor frame itself is properly grounded according to the motor manufacturer's instructions. This typically involves connecting the internal equipment grounding conductor to the motor's grounding terminal, which is usually located inside the motor's junction box. The grounding terminal is designed to provide a direct and low impedance path to ground, minimizing the risk of electric shock. Fourthly, before energizing the motor, thoroughly verify the grounding continuity of the entire system using a continuity tester or a lower resistance ohmmeter. This test ensures that there is a continuous and uninterrupted path from the motor frame back to the service entrance or main distribution panel. Any breaks or high resistance connections in the grounding path can compromise the effectiveness of the grounding system and increase the risk of electrical hazards. In addition to these considerations, it's important to adhere to all applicable local and national electrical codes and regulations during the installation process. These codes and regulations are designed to ensure the safety and reliability of electrical systems and to protect people and property from electrical hazards. The National Electrical Code provides comprehensive guidelines for grounding electrical systems, including requirements for equipment grounding, conductors, grounding electrodes, and bonding. Proper grounding is essential for electrical safety. It provides a low impedance path for fault current to flow back to the source, which helps to quickly trip the overcurrent protective device, such as a circuit breaker or fuse, and energize the circuit. This reduces the risk of electric shock and minimizes the potential for electrical fires. In a delta-configured system, grounding can be achieved using various methods, including corner grounding, impedance grounding, or a high-resistance grounding system. The specific grounding method used will depend on the application and the requirements of the local electrical codes. It's important to consult with a qualified electrical engineer or electrician to determine the appropriate grounding method for your specific installation. Also, ensure that the motor is installed in a location that meets the environmental requirements specified by the manufacturer. This includes protecting the motor from moisture, dust, and other contaminants that could damage the motor or compromise its performance. The motor enclosure should be rated for the environment in which it is installed, such as a totally enclosed fan-cooled enclosure for outdoor applications or a hazardous location enclosure for areas where flammable materials are present. Furthermore, it is important to consider the motor's starting characteristics when selecting the appropriate overcurrent protection device. Motors can draw a high inrush current when they start, which can trip the overcurrent protection device if it is not properly sized. The National Electrical Code provides guidelines for sizing overcurrent protection devices for motors based on their full load current and starting characteristics. It's essential to select an overcurrent protection device that will protect the motor from overload and short-circuit conditions without nuisance tripping during motor starting. Furthermore, to maintain the integrity of the grounding system over time, it's important to periodically inspect and test the grounding connection. This includes checking for loose connections, corrosion, and other signs of deterioration. Any damaged or corroded connections should be repaired or replaced immediately to ensure that the grounding system remains effective. It's also important to keep the grounding system free from obstructions and to ensure that it is not used for any other purpose, such as supporting equipment or running other electrical circuits. The grounding system should be dedicated solely to providing a low impedance path for fault current to flow back to the source. In addition to the grounding requirements, it's also important to consider the bonding requirements for the electrical system. Bonding is the process of connecting all metal parts of the electrical system together to create a common ground potential. This includes metal conduits, enclosures, and equipment frames. Bonding helps to minimize the risk of voltage differences between different metal parts of the system, which can cause electric shock. The National Electrical Code provides detailed requirements for bonding electrical systems, including the use of bonding jumpers and grounding electrodes. It's essential to follow these requirements carefully to ensure that the electrical system is properly bonded and that the risk of electric shock is minimized. Proper grounding and bonding are critical for electrical safety. They provide a low impedance path for fault current to flow back to the source, which helps to quickly trip the overcurrent protective device and to energize the circuit. This reduces the risk of electric shock and minimizes the potential for electrical fires. By following the guidelines outlined in the National Electrical Code and by working with a qualified electrical engineer or electrician, you can ensure that your electrical system is properly grounded and bonded and that it meets all applicable safety requirements. Remember to always energize the circuit before working on any electrical equipment and to follow all safety precautions. Electrical work can be dangerous, and it's important to take all necessary steps to protect yourself from electrical hazards. In summary, when upgrading the plant belt drive motor, compliance with the National Electrical Code is paramount. Firstly, the 2-inch rigid conduit provides a continuous path back to the motor control center, making the internal ground wire sufficient for grounding the motor. Secondly, the use of raintight flex with an internal ground wire is acceptable for short runs where movement is needed. Additional considerations include ensuring proper conduit and flex sizing for the motor's current draw, using approved fittings for connections, grounding the motor frame according to manufacturer instructions, and verifying grounding continuity before energizing the motor. By adhering to these guidelines and the NEC, a safe and compliant electrical installation can be achieved.